When making measurements, it's very important to understand the concept of significant figures, or what sometimes we call Sig Figs for short. When you're writing down a measurement, you always write digits in your measurement. And the digits that, when we're talking about Sig Figs, we're talking about digits that you know for sure, and one digit that you might not know for sure, but it's kind of an estimate. And so there's always going to be one digit that's going to be an estimate, and then all the other digits are hopefully digits that you know for sure, and those digits all together are called Sig Figs. So we want to figure out how many Sig Figs there are in a particular kind of a measurement. And but before we do that, we're going to start kind of looking at some different rulers here and writing down a measurement with the correct amount of Sig Figs. So in this first ruler that we have here, clearly there's not a whole lot of markings on here. There's a marking here, 0, and there's a marking here that goes up to 10. And we're trying to figure out, we're trying to measure how far over is it to that red line right there. How far over is it? And so it'd be interesting to hear what you'd have to say about this. You could start making some guesstimates. Some of you might say something like 7.5. But how do you know about the 0.5? I mean, you're being way more precise than this ruler allows you to be. Some of you might say maybe 7. And what are the units here? Well, we'll just call the units here units. It doesn't really matter what they are. We'll call them units. So you might say 7 units. That'd be a guess. That'd be an estimate. 7 units. But that's all you could say. You can only give me one digit in this particular with this particular ruler. It's a really bad ruler. You could say 7 units. Now, what is important to understand about measurements, and this is really bothersome to students, is that you're never giving me an exact number. You're giving me a measurement, which means there's always some error involved. And so when you say that you think the length of this is 7 units, what you're really saying is that you think it's somewhere in a range of +1 and -1 above that particular measurement that you gave me. So you're saying that if this is 7 units over here, that it's somewhere, but that you're fairly confident that it's somewhere between 6 units and 8 units, one above and one below. And I think all of you would agree that yes, you're 100% confident that the measurement over that red line is somewhere between 6 and 8 units. You're really confident that that would fall within that range. So we say 7 units, but we have to always understand what we're really meaning. We're always referring to actually a range, not a number. It's a measurement. So 7 units means somewhere between 6 and 8 units over. Now this is one Sig Fig. This measurement here has one significant figure. There's only one digit in the entire answer, and it's significant, and it happens to be our estimate. Remember, Sig Figs are going to be all the digits that you know for sure, and one digit that's going to be an estimate. Well, if you only have one digit, then it is your estimate. And clearly you understand, I think, that the 7 is an estimated digit. So this is a measurement here, 7 units. We'd say this line is 7 units long. And we understand in our mind that we're really saying that it falls within a range between 6 and 8 units probably. And there's one significant figure in our measurement. Let's look at a little more precise measuring stick. So we have a better measuring stick here. This costs a little bit more money. The more precise you are, the more cost it's going to be. And we still have the same red line. And I want to find out how far is it over to that red line. Well, wouldn't it be exactly what we got for our last answer? Well, no. You're using a more precise device, and therefore you have to write your measurement according to the precision of the device. So now we look over here and we see, well, there's the 7 line and there's the 8 line. So we know we were right. We were at least somewhere between, 6 and 8. But now we can say that this is 7 units, 7 point, and we can make another estimate somewhere between the 7 and 8. And I don't know what you would guess. I would say maybe 7.2, maybe 7.3, one of those I'd say. Okay, 7.2 units. Okay, now, is that more precise? Yes. Is it an exact number? No. Measurements can never be an exact number. There's always some a range involved. So what do I actually mean when I say 7.2 units? I mean I'm fairly confident that my measurement is somewhere between 7.1 and 7.3. See, one above and one below my estimated digit. So 7.2 doesn't actually mean 7.2. It means somewhere between 7.1 and 7.3. It's a lot more precise than just saying 7. So how many significant figures does this measurement have? Well, it's all the digits that you know for sure, and the one digit that is an estimate. So we know the 7 for sure. The 2, however, is an estimate. So both of them get counted, and this measurement has 2 sig figs. Let's look at a little more precise measuring device. Okay, so now we have even more markings on here, and we can say that this is definitely a 7. It's past the second line, 7.2. And where is it? Well, we're going to have to estimate again. So 7.2, and it looks like it's almost close to the 3. So I'll say 7.28 units. 7.28 units. Now, do I know it's exactly 7.28 units? No. It's not a number. It's a measurement, which means that 7.28 units means that I'm pretty sure that it's somewhere between 7.27, see, one below, and 7.29, one above. It's somewhere within that range, which is a pretty narrow range now. So I'm much more precise. I still don't know things exactly. I never will know a measurement exactly. There's always just smaller and smaller ranges of precision. So how many sig figs are in this measurement here? Well, I know the 7 for sure. I know the 2 for sure. The 8 is an estimate. And so all 3 of those are significant digits. So I have 3 sig figs. Okay, so hopefully that's a little explanation of what significant figures are. We need to write a measurement with the correct amount of sig figs in it. And it's going to be very helpful if I give you a measurement on the test and you be able to count up how many of these digits are significant right away. So there's a method that I use for this. I call it the Pacific Atlantic method, where you have the United States is going to be your measurement. So I'm going to write down some kind of a measurement. I'll write down a measurement here. I'll write down 1,040 units. And I want you to tell me how many of these digits are significant and how many aren't. So the way we use this method is the Pacific Atlantic method. You'll know that the Pacific is over on the left side and the Atlantic is over on the right side. And what this refers to is I'm going to ask myself a question. Is there a decimal point present or absent in this measurement? Present or absent? That's the question you're going to ask every single time. I give you a measurement. You ask, is there a decimal point present or absent? Of course, you'll see there is no decimal point here, so it's absent. What that means is we're going to start on the right side of our measurement. We're going to start over here on the right side of our measurement, and we're going to go through the measurement in this direction. And we're going to start counting sig figs whenever we get to a digit that is not a 0. As soon as you get to a digit that's not a 0, you'll start counting from that point all the way to the end. So I look at my first digit and I see that's a 0. So I'm not going to count that one. I go to the next digit and that is not a 0, so that's where I'm going to begin counting, and I will count 1, 2, 3. This has 3 significant figures. That's how we're going to use Pacific Atlantic. So let me give you something else. 202.050. There's a measurement. Is their decimal point present or absent? And you'll see that it's present. That means we're going to start on the Pacific side. Hopefully you understand that Pacific and present go together, and Atlantic and absent go together. Maybe that wasn't obvious. I'll state it. A and P. So, is a decimal point present or absent? In this case, it is present. So I'm going to start over on this side of the measurement, and I'm going to go through the measurement in this direction. So if there's a decimal point present, start on the Pacific side and go through from left to right. If it's absent, start on the right side and go from right to left. So I'm going to start going through this measurement from left to right. I'm not going to start counting until I come to a digit that is not a 0. So the first digit I come to, you'll notice, is not a 0. So I'm going to start counting there, and I'm going to count all the way to the end. 1, 2, 3, 4, 5, 6. This has 6 significant figures. Let's try another one. The measurement 100. How many significant digits are there? Well, is a decimal point present or absent? It is absent. So we're going to start over here, and we're going to go through this way. Don't start counting until you get to a digit that is not a 0. That first one, that's a 0. That's a 0. This one is not a 0, so I'm going to start counting right here. 1. 1 significant figure. Let's try another one. 10.050. Decimal point present or absent? There it is. It's present. We're going to start on this side, and we're going to go through this direction. So I start here. 1, and that's not a 0, so I'm going to count it. 1, 2, 3, 4, 5. I begin counting at the first digit that's not a 0, and I count all the way to the end. Don't worry about all these other zeros. As soon as you get to a digit that's not a 0, begin counting from that point and go all the way to the end. Pacific Atlantic is a really good method. If you study this in college, you're going to find textbooks that have entire a page that's devoted. It has like 10 different rules on whether it's a 0, whether it's before or after a decimal. There's all kinds of rules. Well, you don't have to abide by any of those if you understand Pacific Atlantic. If you can do Pacific Atlantic, you can always easily count how many sig figs something has. So let's try another one here. 0.020. Okay, is a decimal point present or absent? Well, clearly it's present. It's right there. So where do I start? I start on the Pacific side over here. And I'm going to go through the measurement in this direction. I don't start counting until I get to a digit that is not a 0. So this, no, that's a 0. This one, no, that's a 0. This one, there we go. There's a digit that's not a 0. I'm going to begin counting right there. 1, 2. So this has 2 significant figures. You'll notice in this measurement, these 2 zeros here are not significant. They're not actually part of the measurement. They're just placeholders is all they are. They're not actually part of the actual measurement. But this 0 is significant. Otherwise, why would we have put it down? Why would we have written it down? Why wouldn't we just said 0.02? Well, we actually know that this 0 here happens to be an estimate in the measurement. So we would write it down. The only reason you'd ever write that 0 down is if you are confident or pretty confident that that's one of your parts of your measurement. So, Pacific Atlantic method, hopefully that will help you be able to figure out how to count how many sig figs a measurement has. So we'll QED that and call that good.